Good morning to all. Our next topic is same like previously what we did, the Laplace transform circuit analysis. So in that case, we'll solve some numerical problem, with starting with some concept which is we left in the previous lecture. So if we closely look, we have with the Laplace transform two conditions. One is called as a zero initial condition, and second one is called as a initial condition. So already the problems we have seen with respect to the zero initial condition with initial condition. I will just remind once again what is the main difference. So for the case of register, if we take in the time domain, that is in the equivalent circuit model. So V of t is applied voltage, the current I of t will flow and it will pass the register. Then it is, if we calculate apply the Ohm's law and we'll calculate the value of R. So this is in the time domain. If we'll go for the with zero initial condition means V of 0 is actually the voltage, initial voltage is 0, initial current is 0. So the register, there is no change in the register, then V of t is become V of S and I of t is become I of S. The same thing we'll see with initial condition. So there is no change because for initial and with initial condition, for the case of register it is same. But this is not in the case of inductor. When you can see the equivalent circuit model in the time domain, V of t voltage is applied, the current I of t will flow, and this is here the inductor. So when we'll go for with the zero initial condition, it is the V of t is become V of S, then I of t is become I of S, and for with the zero initial condition, the current is 0. So for that case, it is SL. But for the case of with initial condition, if you have a value of I of 0, so you can see here we have two different conditions you can use as per the circuit requirement. So you can connect inductor with voltage source in series and the inductor with current source in the parallel. So here you can easily put your initial values of the current and you can do the solution. Now for the case of capacitor, for the equivalent circuit model, you can see V of t, that is in time domain, I of t current is the time domain which is flowing through the capacitor. Will apply the Ohm's law and will calculate the value of capacitor. With the zero initial condition, the V of t is become V of S, I of t is become I of S. Then we have here the value of SC. But for with initial condition, we have two different conditions again. The capacitor is series with the voltage source and capacitor is parallel with current source. If we know the value of V of 0, we'll put here V of 0 value and we will do the solution. This is completely depend upon the demand of circuit. Now we will take one very simple example, which is actually, if you closely look, this particular example is with zero initial condition. So the circuit is in time domain. You need to convert to the frequency domain all the values like 10 e to the power t u of t, 1h, 2f, 4 ohm and 3 u of t. So now you can see we'll convert to the S domain. So your circuit is look like the same, but the values are 10 divided by S plus 1 and the inductor value is S, capacitor is 1 by 2 S, and we have a 4 ohm, the current is 3 by S. This question is basically for zero initial condition. So that is the reason we are not taking anything for the case of capacitor and anything for the case of inductor, because for the case of inductor that initial current is 0 and for the capacitor the voltage is 0. Okay, then after that we'll apply the nodal analysis in the particular circuit. So tan S plus 1 minus V naught divided by S plus 3 by S equal to V naught by 4 plus 2S V naught. So here our we can easily calculate the value of V naught. So V naught is finally 15s plus 25 divided by s plus 1 multiply with s square plus 0.25s plus 1. And we will go for the partial fraction a by s plus 1 plus bs plus a by s square plus 0.25s plus 1. Now our job is we need to calculate a, b and c value. So we can use algebraic method or residual method. So here you can see the a value is 40 by 7. So the b value is minus 40 by 7 and c value is 135 by 7. After that, we will put this all the values in the previous equation. Then we will take a inverse Laplace. So you can see here, this is we can put the value now. So after putting the value, we have a complete equation. You can see here, that is 40 by 7 s plus 1 minus 40 by 7 s plus 1 divided by 2 s plus 1 s plus 1 by 2 whole square plus 3 by 4. So we can arrange in the form of actually after for in the form of Laplace property for taking the inverse Laplace, and finally we will write our equation in the time domain, because our question is in time domain. So that's why we have to take the complete solution in time domain. We will take one more example. So you can see the switch is moving from position 1 to position B at t is equal to 0. We need to find the V of t value. So so for this case, if that is the switching condition, when the switch means switch at position number 1, what is the circuit? Then switch move to position number 2, what is the circuit? If the switch is position number 1, you can see we have a circuit like this. Correct? We have a circuit like this. So in this case, this is where the 12 volt, and this is where basically the capacitor. So for that case, when the switch is moving from position 1 to position no, the switch is in position 1, so we have a V naught value is the initial voltage is here 12 volt, yes. And what about the current? Current, because it is an open circuit, so current is how much? We have a 0, correct? But so this question is basically for the bit initial condition, because we got the value of V naught of 0 is 12 volt. When the switch is moving from position 1 to position 2, okay, so we have a circuit like this. Now you can see here, we didn't use when the switch is moving from position 1 to position 2, okay, so your circuit is look like this much circuit, correct? Okay, so here here the thing is that for the initial condition, this inductor is not connected. So what is the meaning? For the initial condition, only capacitor plays the important role. Okay, so that is the reason for the capacitor we have two conditions. Either we can use as a current source, or we can use as a voltage source. Okay, so as per the demand of the circuit. But for this case, we have used here the current source. Now, what is the initial voltage? Initial voltage is V of 0 is 12 volt. But for the case of current, the current is 0. So that is the reason we have only the inductor here, and the capacitor is connected with the voltage source. Now we will do the solution, and finally we will calculate the value of V. So what is the value of V here? What is the value of V here? Simple. Simple we can apply. Okay. So here I is 12 by s divided by s plus 4 plus 100 divided by s, or we can write 48 s square plus 400. Then the V is 12s divided by s square plus 400. This one we can arrange into the form of that we can say property. So the property is 12 cos 20 t. So you can see very simple circuit. Okay, with initial condition we did we got a new circuit and we got a solution. Apart from this, we can take one more solution. You can see here this solution again. The initial find V naught of 0 for all t is greater than 0 is okay. We need to calculate the V naught of 0 here. V naught of 0. So for this case, I and the initial voltage and initial current is 0. Okay. So if the initial voltage and initial current is 0 for the t is less than 0, so directly we can convert to the time domain to frequency domain. So now we can see here, that is in the time domain to frequency domain, 2 u of t 2 by s, u of t 1 by s, 1 ohm is 1 ohm, 1 ohm is 1 ohm, 1 h is s, and 0.5 farad is 2 by s. Because of initial value is 0, so there is no connection for the capacitor and no connection for the inductor in terms of voltage and current. Okay, then we can do the further solution. We can apply the node, we can apply the match, okay, we can apply the superposition. Same problem will solve using the superposition principle also. You can solve using the node method also. Okay, so likewise we'll do the complete the finally we have to arrange the solution in the form of the partial fraction. Then finally we will use the properties taking the inverse, and our v naught, capital V naught is become, after taking the inverse, that is the v of t. Likewise, we will take one more problem. If V naught of 0 is minus 1 volt, what is the meaning? Initial voltage is 0. Then what is the solution of the V of 0? So this is the circuit. You can see here the difference. So this particular this particular capacitor, we have two conditions. Either we can use current or we can use the voltage source. So here basically we are using the voltage source, V naught by S. So what is the value of V naught of 0 is minus 1 by S. Then we have we can solve this circuit very easily using the nodal analysis. And you can see here V naught is A by S plus B by S plus 4. So A is 7 by 2 and B is minus 9 by 2, and V naught is 7 by 2 minus 9 by 2 e to the power minus 14 watt. So the thing is that we have a lot of solutions for initial conditions. Okay, so the main thing is properties of the Laplace transform. You have to go through all the properties. Okay, and based on this video lecture, I will take one quiz, and you have to solve the problem. The quiz is MCQ, and and you have to just tick mark for the all the questions. Okay, thank you very much.